So hi, I am Daiana, and I work as a software engineer here at Bosch. I mainly develop computer vision and deep learning algorithms, and yeah, we work in the rail industry for this.
So, de la dosar cu șină la șină de tramvai.
Literally șină. Okay. Okay, so yeah, we're going to talk about building the foundation for rail automation. So me together with my colleague Ovidiu. Yes, okay. So what do we have for today? Yeah, first we'll say a few words about this topic of automation, but for the rail industry. Then we will make an analogy with how us as humans perceive the surroundings. And then we're going to talk about the product that we develop in our department, BG, and that's called the Bosch Tram suit. Yeah, so regarding this topic of automated driving, you're probably familiar with it, but mainly from the automotive domain. Well, for rail, it's a similar approach. We basically have these grades of automation. We have grade 0, where the driver does everything manually. And then we have up to the 4th level, where the tram can just drive by itself, so there is no need for human intervention anymore. Yeah, our approach is a gradual one, because first, when we want to go from one level to the other, we try it in depot scenarios, because it's an environment where we can better control it and have these low-speed applications. And then we do the level up to city drive. Yeah, as I said, we decided to make this human analogy to explain how an automated system like this works on a tram. And yeah, let's just take an example. How are we doing when we are in traffic? We see a green or a red light, and what are we doing? So we get first the information with our eyes, then we process it with the brain, and then we take action using our muscles. So either we move or we stop. That's what we decide. So an automated system that is on a tram, yeah, it's a similar approach. Maybe it's a naive comparison, but to understand it better, it just uses some other tools. So hope you like the AI generated images. The main component is the eye. And yeah, for the tram or for the system that is mounted on a tram, that's represented by multiple sensors. And I will present you the set of sensors that we have. So we are using the primary eye, how we called it, and that's the MPC3 truck camera. It's our Bosch camera. And has a system on chip that performs AI algorithms. So we have neural networks that are detecting, for example, the traffic lights, the persons, the vehicles, or the turnouts, for example, in case of the tram. Yeah, and we also have the semantic segmentations for the track. Then we have the all-weather eye. That's the 4th generation of radar. And with that, we measure the distance to objects, and that performs well in different weather conditions compared to the camera, for example. Yeah, we have the 3rd eye. That's the LiDAR. And as you may know, it provides the 3D point clouds, which helps us, for example, detecting the free space or detecting any obstacles. And then we have the 6th generation of ultrasonic sensor, and this usually helps in low-speed application, for example, detecting the platform or for the coupling assist. Okay, so we have all this information. What's next? Yeah, we process it with our brain, but for an automated system, on a tram, of course, it's named RPU, Rail Processing Unit. It's basically just a control unit that fuses the output from all the sensors. It processes it, and then it takes a decision. If we take a basic use case, we detect a person in front of the tram, which is in the collision area. And we also have some other information, for example, that the tram has a speed of 20 kilometers per hour. We analyze all this information, and we identify a potential risk. So what's next is to warn the driver. Yeah, and the third component, as I said, are the muscles that for us, they help us to take action. But for a system that is mounted on the tram, this can trigger, for example, acoustic or visual signals, like a buzzer or whatever, and that can be implemented, that can be done with an HMI, for example. Yeah, in critical scenarios, of course, we can also trigger the automated braking system. Okay, and in order to improve our system, we have two other components that are pretty important. One is regarding the localization. So for that, we have this IMU that has an accelerometer and a gyroscope that basically provides the information about how we accelerate or how we brake or how are we changing our direction when we are in a curve, for example. And besides this, we also have a GNSS that provides the absolute global coordinates. Yeah, and the other component is related to the connectivity and communication part. And for that, we can connect to a Bosch cloud instance, and we can also update our software. So, for example, if we update the neural networks, we don't need to go there on the tram, but we can do it all remotely using this over-the-air technology. So this is like a basic explanation of how it works and the sensors that we are using. And now, as I said, I will let Ovidiu present you our product.
Now we are going to analog tapping the screen. Okay, so the tram suite, it's a collection of different ADAS systems which can work together or they can work individually, some of them. The base of the entire tram assist is the forward assist. Okay, we have to tap on forward assist. Okay, forward assist uses the MPC3 and generation 5 radars, detects different objects like buses, trucks, detects the trucks, the motorcycle, two vehicles, different cars, also speed signs and different signals. For example, can detect speed limitation and send an information to the tram controller to change to stop or to brake, and can also detect a red light, for example. Tap to continue. Okay. We can warn up to 80 kilometers per hour and avoid collision up to 45 kilometers per hour. Usually the trams, the speed of the tram are limited in almost the majority of the networks up to 50 kilometers per hour, I think. But there are some networks where they can go with a higher speed. Tap to continue. Okay. We can, here are some use cases presented. We can also detect trams which are coming from the flank, and adapt also the speed to the tram speed. If you are tapping, we are following the tram which comes from the, yeah, you can tap. We are following that tram, and we know which the radar knows the speed of the tram from forward, and can send the information and adapt the speed of the ego tram by following that tram. Okay. Now we are going to the next. By adding a LiDAR, which is later development, adding a lidar, we can decide, or the tram can decide if he can pass a car or an object which is very close to the tram gauge, and yeah, this is done by the lidar, and lidar can also detect people who are laying down or something like that. Okay. The next system, it's near range assist, uses ultrasonic sensors, and the use cases are those ultrasonic sensors can detect the platforms and decide or send information which door should be open, the left or the right side. And other use cases for the near range assist are the climbing. You can tap the climbing people, and also, yeah, which are climbing on the coupling. Some of the trams have couplings outside. And also, for example, here, if we start, and it's an object which is not seen by the driver, the system can alert the driver is something in front. This is why I think the product it's very good for retrofitting, for example, because the old trams do not have do not comply with the latest visibility standards, for example, and they should detect the child at 60 centimeters around the cabin. Okay. The flank assist, for example, it detects and warn and make the driver aware that it's an object which is traveling and has a high plausibility to enter in front of it. Yeah, from the blind spots of the tram. Also, the tram has some blind spots, so this is one of the use case of the flank assist. We can go further. And basically it extends the area which is monitored by the forward assist. It extends that area also in that blind spot. Focus assist, it's monitoring the driver and his attention. Maybe the driver is not there. Maybe the driver has sleeping. It's a micro sleep, or he's talking at phone, or he's talking, or he's smoking. These kind of things can be detected by the infrared camera, which is used inside the cabin. So I think this is the last product that we decide now home. We are going home. Is the last product that we decided to present here. Of course, the use cases are these are just a few of the use cases that can be implemented using all these sensors, and yeah, I think it's just one switch to the last page, and it's a QR code there. If you want to have more information about the product, yeah, you can scan it directly. Ultima pagină. Da. Cu telecomanda. Okay. So if you have questions.
Finally, an automotive presentation today.
Okay. So this is a 10 minutes presentation because the subject is, yeah, of course, we could, the first time we tried, we had, I think, 30 minutes.
Yeah, it's definitely longer presentation. And you can, I was, asking Daiana, so basically you can apply this to trains, the plan is to apply this to real train, not necessarily tram.
Yeah, also to trains.
Yes.
Yeah, can be. Yeah.
Okay. Not about management, no?
It leads to that. So, what is the standard of safety that you follow? The one from automotive or the one from railway?
Rail has its own standards, so of course
Yes.
the
And do you have it implemented?
safety. It's not a safety relevant product, let's say like that, because it's just an assistant system. So driver is always in control and he decides if something it's okay or not, because sometimes he will consider that doesn't need to brake. He can decide, okay, we will brake later. He has always the possibility to. But if we go to the automated driving, then yeah, the things will change. But we are far away from there right now. Then we will need a still safety level for sure. Sorry. Not really. It's not. It's ongoing. So yeah.
But this tram is in Cluj, right? I mean, it's implemented, it's running in Cluj.
So in Cluj, we have a project together with City Hall, University, Technical University, and CTP, of course. They have the tram. There it's a TFCW product, which is a serious product. We have it all around the world. We have more than 3,050 system delivered. It's the actual.
So there's the production.
Yeah, that for that one, yes. The forward assist is the next level. We improve, we change the components, we upgrade the components, and this is still under development. But we already have it and did some tests on the tram in Cluj.
Okay.
So it's
So that's
a live
development
lab.
too,
It's a live lab where we can test our products.
Sounds great. Okay. Any more questions?
I would like to know what type of testing are you using? Are you using real-world testing or mock data, or what's the process?
So we are doing measurements. We are going with the measurement equipment. We are collecting data. We see resimulate for some new versions. But of course, the release is done, I think, directly on the field. We are doing some tests.
One detail, I forgot to tell you that we'll give free invitation 20 days, but we'll start from here because we forgot to monitor you. Okay. Any more questions? Okay. And when do you think we'll have a train in Romania that will run with this?
When they pay it. So the product it's ready to be installed from our point of view. We will have it next year, I think, for series. We already have the hardware of the core of this tram suite, the forward assist, and yeah.
Oh, sounds great. Yeah, hopefully they will get some, European money maybe, or who knows.
Yeah.
Okay. Thank you very much.
Thank you.